So what is a unit vector? Well, a unit vector is a vector where the magnitude is equal to 1. So let's say we have a vector like this, 0, 1. The magnitude of this vector would be 1 because if you use the Pythagorean theorem on both these numbers, the value turns out to be 1. Okay, let's start this off by saying there's a point P at 0, 0. So there's a point Q at 5. Let's actually do 3 and 4. What is the vector between P and Q? So P and Q are points here, and let's say here. So this is Q, and this is P. What is the vector from P to Q? So the vector from P to Q would be the distance between two of the 2 points of x and the distance between the 2 points of y on both the points P and Q. So what's the distance? Since P is written first inside of this, I guess, vector variable or vector representation, since P is written first, we find the distance between P and Q, but starting off with the x variable on P. So what's the distance between 0 and 3? Well, the distance between 0 and 3 is, well, 3. So the x value of this vector would be 3. What's the distance between 0 and 4? 0 and 4. It'd be 4. Now, just a quick side note, if this value was, let's say, -4, it would be the distance between 0 and -4 because P is the first listed point inside of this vector representation. So, what would the value be? Well, the value of this would be -4 if and only if Q had the y value of -4. Now that we have that, now that we have this vector, what we can actually do is use the Pythagorean theorem. So in the previous video, I covered how to find magnitude. But in order to find the magnitude here, let's draw a dotted line to show this. So P has a value of 3 on the x-axis. So now that we know what points these are, we can just erase them. If P has a value of 3, then the x value would be 3 here, and the y value would be 4 here. So if the x value and the y value are 3 and 4, what does this look like? This looks like a right triangle. We actually have a right triangle here. So we can use the Pythagorean theorem. Let's go ahead and use that. Dude, I need an iPad, bro. 3 squared plus 4 squared is equal to 9 plus 16, but this is a Pythagorean identity, so we get square root of 25, which is equal to 5. So the magnitude of this vector is equal to 5. But how do we turn this into the unit vector version of this? Well, all you have to do is, if the length of this is 5, then you just divide the vector, all the values of the vector by 5. And what I mean by that is, let's go ahead and erase this for more space. Let's leave magnitude 5 over here. Magnitude equals 5. What I mean by that is PQ, right, is, I don't even know why I wrote that down. Okay. We'll just multiply, or we'll actually divide both the values of this vector by 5. So you can actually multiply a scalar or a real number by vectors, or multiply a scalar onto a vector and just distribute this value onto each value inside the vector. So what this equals is 3 over 5, comma 4 over 5. What happens is, if you divide all the values inside a vector by its magnitude, so if you divide these values right here inside P of Q by the magnitude, which is 5, you'll get the unit vector. And as a result, the unit vector's magnitude, by definition, is 1. So let's go ahead and just show this real quick. Let's actually use Pythagorean theorem on this new vector, and this new vector will actually look something like this. It's still has the same direction. So unit vectors have the same direction as its original vector. So it'll still point the same way, but the magnitude will just be 1. I'll actually show that to you by using the Pythagorean theorem on these two values. So let's go ahead and do that. 3 over 5. Oh my god. Oh my god. Oh my god. My numbers look horrible. You know what? I'll just... Bro, I hate doing this. You know, let's draw this up here so we have more space. Parentheses. Those look better now. Plus, parentheses, 4 over 5. And then we'll get square root of 9 over 25 plus 16 over 25, which is equal to 25 over 25. And this is just equal to literally 1. 25 over 25 is 1. Square root of 1 is, well, 1. So the unit vector of this is magnitude is equal to 1. And what did we do? We just found the first vector. So we found the first vector p to q by finding the distance between the corresponding x and y values of p and q. And I forgot to erase the negative here. And then, now that we have this, we just find the magnitude of this vector, or the new vector here. So we found the magnitude by using the Pythagorean theorem. The magnitude was equal to 5. And then divided it by 5. So we just divided the length of this vector by 5. So 5 divided by 5 is equal to 1. And that's what we try to get. 1 is the new magnitude of the unit vector, which is this little guy right here. So, solve for a vector with a given length. Now that we have a unit vector, what can we also do? Well, if you have a vector, let's say the previous vector 3, 4, the Pythagorean identity with a magnitude of 5. What if we want a magnitude of, let's say, 10? What we can actually do is just multiply each value by the scalar 2. And if we do that, that gives us 6, 8. What happens to the magnitude here? Well, let's go ahead and do that. 36 plus 64 is equal to square root of 100, which is equal to 10. That's the same thing as multiplying the magnitude by 2. So what can we actually do? If we want to find a specific magnitude, we can just multiply by whatever number will get us to that magnitude into these vectors. So let's go ahead and try that out. Let's say we have a vector. Let's say we have a points, 2 points actually. P, let's say like, I don't know, 2, -6. Then we have Q, 9, -10. Find PQ first, so just go ahead and do this. Find PQ, the vector P to Q, and see what that equals. I'll do that really soon, and I'll do that right now. So the reason why I wrote 7 first is because P is the start, so we see the distance between 2 to 9. How much do we have to add to 2 to get 9? Well, we have to add 7, right? So the first number is 7. And the next number would be -6 and 10. What's the distance between -6 and 10? Well, how do you get -6 to -10? You subtract it by 4. So the next vector value would be -4. Now that we have this, let's find the magnitude. The magnitude is equal to the square root of 7 squared plus 4 squared. And the reason why I left out the -4 here is because if you square it, it'll end up positive anyway. So I just absolute valued the 4 here. And then you get 49 plus 16, which is equal to the square root of 65. So now this is the magnitude. This is the magnitude of this vector. Square root of 65, let's leave that up like, I don't know, like down here. Magnitude. equals square root of 65. Now that we have that, let's say we want to find the length of, I don't know, like 8 of this vector. We want to set this unit vector, we want to set this vector p to q to equal the length of 8 while still facing in the same direction. So what do? Unit vectors, remember, unit vectors, so let's say this is the original vector, unit vectors will face the same direction, they just have the magnitude of 1. So what we want to do is find now a new vector that has the magnitude of 8. But how do we do that? First step, we have to find the unit vector. Let's go find the unit vector. So we already found the magnitude of this. The magnitude of p and q is equal to 65. So what do we do to get the unit vector? We just divide each value by square root of 65. Each value in p of q by square root of 65. Let's just literally just do that. P of q. Let's call this u unit vector p of q. This is not actually how you name it, but I'm just it's not how you name it at your actual Calc 3 class, but I'm just going to differentiate it like that. The u at the beginning. So we just divide it by square root of 65, the magnitude, to get square root of 65. And this is the unit vector here for p of q. This will face the same exact direction as p of q did, but now the magnitude is 1. So what do? We can actually multiply each of these values here of the unit vector. So we can do 8. Let's separate this. 8 times unit vector of PQ. Since this magnitude right here is 1, magnitude right here is 1, and we want to get a magnitude of 8, how much do you multiply 1 by to get 8? Well, obviously, you multiply 1 by 8 to get 8. So that means we have to multiply u of p. No, stop, not u of p. The vector p to q by 8 to get a length of 8. Let's go ahead and do that. 8 times 7 square root of 65, comma negative 4 square root of 65. And then what do we get? Well, this is equal to 56 because I multiplied 8 by 7 over, wait, I need to put the brackets. 56 over square root of 65, and we'll multiply 8 by 4 now. And then you get 32, and the negative stays over square root of 65. Dude, I hate drawing on a mouse. Okay. This right here, now the magnitude of this equal to 8. So whenever a question says, gives you 2 points or gives you a vector, whenever a question gives you 2 points like this, or it gives you, like, let's say a vector 2, 9 or something like that, anything random, and it tells you to find another vector that has a different magnitude. So let's say you 2, 9, and it's telling you to turn this into, let's say, magnitude 10. Obviously, this isn't magnitude 10 right now. This right here is the square root of 4 plus 81, which is equal to the square root of 85. That's the magnitude of this current vector. So how do you find the magnitude 10? How do you turn it to magnitude 10? You find the unit vector, so let's call this I don't know, W. Let's call this W vector. Find the unit vector for W, and then you multiply it by whatever magnitude you're trying to find, because right now the magnitude of this is 1. So obviously you multiply 1 by 10 to get 10. Let's go ahead and do just one more problem. Instead, for this problem, I'm just going to show you I. I'm going to represent the vector as as with the I hat and j hat. Say you have a vector 15, 15 I hat with 10 j hat. So let's call this vector P. So go ahead and solve this for magnitude. Want the magnitude to be, let's say, 81. So go ahead and try to solve this. Okay, I'm going to work through the problem now. So P vector, the vector P, is also equal to 15, 10. So J literally just stands for the Y value of the vector, and I just stands for the X value. So all I did was just move 15 down here, move 10 down here. So this is the vector, what you've been seeing previously, and what you're probably comfortable with. So we're going to find the magnitude of this vector. To divide it, to find the unit, divide P. So we're going to find the magnitude here to divide vector P by that magnitude to get the unit vector P. So 15 squared is equal to 225 plus 10 squared, which is equal to 100. So what is equal to square root of 325? And the square root of 325 is equal to 513, I think. Hold up. Yeah. So the magnitude of this vector is the magnitude of P is equal to 5 square root of 13. So let's find the unit vector for P. Unit vector is divided by whatever magnitude that you found. So 15 divided by 5 over square root of square root of 13 is equal to this. 10 5 square root of 13. And what do we also get? This is equal to 3 over the square root of, what? 3 over the square root of 13, comma, 2 over the square root of 13, because I divided 10 by 5. So divided the 10 by 5 here and divided the 15 by the 5 here to get the 3 and the 2. So now this is the unit vector. This right here is a unit vector for P. And if you just do Pythagorean theorem on this, you'll get 1 as the value here. Let's not do that. We're trying to find the magnitude of 81. So what do? If this current magnitude is equal to 1, what do we multiply 1 by to get 81? Well, that's easy. We just multiply it by 81. So let's go ahead and do that. Let's multiply this vector, the unit vector, by 81. Let's write that down over here. 81 times 2 square root of 13. Oops. It's 3 square root of 13. 3 square root of 13 and 2 square root of 13. Multiply 81 by each value here. What do we get? 81 times 3 is equal to 243 square root of 13. And 2 times 81 is equal to 162 divided by square root of 13. And then now, if you calculate the magnitude of this, you'll get 81. Let's go ahead and do that real quick. Square root of 243 square root of 13 plus 162 square root of 13. Let's square these values. Holy ugly parentheses. Okay, bear with me on these ugly parentheses. I know it's hard to sit through, but I have to sit through them as well. So 243. Let me pull out my calc right now. Calc is short for calculator too, by the way. So this squared is equal to, this fraction right here squared is equal to 59049 over 13. Let's do 162. 162 squared. 26244 divided by 13. And honestly, I'm just going to use Mathway. Shout out to Mathway. To solve for this because I'm lazy as fuck. Yeah, I recommend if you got these like long ass operations to do, yeah, just don't even do them yourself, bro. Like especially if you already know how to do like division, which I hope you know how to do division and square roots. Then by using Mathway, I got 81 here. So this now is the magnitude of 81. Because we multiplied this unit vector right here by 81 up here to get this new vector, we got the magnitude of 81. So what do? Basically, the gist of this is find the unit vector and then multiply it by whatever magnitude you're trying to get. Thanks for watching. If you have any questions, put it down in the comments section. Everyone have a nice day.